Okay, before starting Newton first, second, third law, the statement of Newton first, second, third law is also not going to be asked in your exams, but we need to know about the concept because that is included in numerical section. So concept is important, definition is not important. So let's suppose before starting the Newton law, there is a very interesting concept of inertia. So first of all, we need to start in your daily life. Let's suppose uh, how many of you knows to drive a car, or
I
how many
do.
of you try
I
to
do.
drive a car? Okay.
I do.
Yeah.
Okay. Okay, if someone is not driving a car, maybe you have experience of cycling or roller coaster ride or the
Yeah.
car.
Yeah, that
So
I do.
yes.
Yes.
So everyone has some experience of driving, riding like this, right? So, or if someone have no experience, so no issue. We saw in the movies also that someone is driving a car and suddenly he or she applies a brake. So what happens with the body who is actually driving with
It
the
it
driver?
it it moves front like really
It
fast.
stops with like a jerk suddenly
Yes, yes,
if
it
it's
suddenly
sudden
moves
break.
forward direction, right? If we apply brake. And what happen if someone tries to jump from the bus or from the car? Just like the
That I haven't tried it, but if you
yes,
jump, you just
yes,
roll like
yes,
you'd be rolling for a little
direction, in forward or
You
in
will
backward.
suddenly
to the
go
opposite direction of
in
where
the
the bus
opposite
is going.
direction of the bus also because there's air resistance, so it will suddenly take you.
Okay, okay, actually this is a natural reaction, right? When we applies a brake, so actually intentionally we are not trying to move in forward direction, right? That is normal. So actually this is
Yeah.
connected with inertia. Inertia is actually an internal property of a body. That is our built-in quantity, that is not like scientific or external or applied force or quantity. It is natural, right? If we applies brake, so suddenly we move in forward direction, then we comes to rest state, right? Same goes, let's suppose if someone is moving in reverse direction, reversing the car, and if he or she applies the brake, so what actually happens? We first move in backward direction, then we comes into rest, right? But we are not able to observe that backward force because on our back side we are having a seat. So forward example is very much common. So that is the concept of inertia. So basically, if we want to write the definition or the concept of inertia, so inertia is intrinsic property of a body, intrinsic property of a body, which is the change.
Still, what is the first word you wrote in the definition?
Intrinsic. Sorry, I
Oh,
write it wrong. It is intrinsic, not intrinsic. Okay, same goes. Let's suppose if someone is standing or passenger is standing in a bus and he has no support. He's not holding any cable or any handle. So let's suppose if driver suddenly applies brake. So what happened with the passenger?
He will fall.
they
Yes, he will
fall.
fall in forward direction. So actually, passenger is not trying to move in forward direction, or he will never wish to fall in forward direction in front of all other. But that is natural because when we are standing on the surface of a bus, so our body is in motion state, right? And according to the definition of inertia, it is internal property of a body that actually resists the change in a state of a body. So we are in motion state. So when we applies brake, so actually we are trying to change our state, but we are in motion state from our starting point. So our body tries to stay in the same position or in same state. So that's why we move in forward or in backward direction. That will be always opposite, because we are moving in forward direction in a car, and when we applies brake, so the meaning of applying brake, that now we are not going to move in forward direction anymore, but our body has property that our body tries to move in the same direction or continue its state of motion, right? But due to inertia, there is a sudden change in our state. First we move in forward direction, that's why we use seat belts, right? Otherwise we collide with the steering or the dashboard of the car. So that is the concept of inertia. It is completely we can say that it is a natural property of a body. It is not a forced quantity or some other quantity, right? And there is also a magic trick or experiment you call that. Let's suppose if you have a regular cold drink bottle or any other bottle, and you placed a card over it and a coin over it, right? And when you try to pull out that card very quickly from under the surface of the coin, so coin or that marble will fall in the bottle, right? So what actually
Wait,
happens?
what? Can you show this? I don't know what you're talking about.
Okay, let me show you this. It is also a very famous old magic trick that there is a dining table and there is a sheet under the cloth sheet under all the objects placed on the table, and someone tries to pull that sheet with a jerk, and all object will remain in their original position, and you just remove that from other object. Let me show you. So actually that is the concept of inertia. Okay, you also observe this experiment. There is a jar and we placed a circular coil or circular roll of the tape, and we placed coin over it, right? And with the help of the pencil of the pen, we try to uh, pull that tape or that roll under the surface of that coin, and coin will fall in downward direction. I hope that you observe this experiment or somewhere.
No, I haven't.
Okay, if you don't
I've
observe that, so
seen
try
this.
by yourself. Okay.
I've
uh,
done this.
okay, yes, because in school we used to try this experiment. So actually what happens over there, what is the science behind this? Actually, this coin is in rest state, right? Coin is in rest state, and coin also have property of inertia, right? So when we try to pull that roll suddenly or in a jerk under the surface of the coin, so coin continue its state of rest, right? Because according to the definition of inertia, it is the intrinsic property that resists the change. So actually inertia helps coin to remain in the same state of rest. That's why coin fall in the jar, coin will not move with the surface of the tape or that roll, right? uh, Another experiment is this one. You can simply perform this experiment too. Just place a card coin over it under the,
Oh, okay, that's what you were saying. Okay, yeah, I
and
understand
try
that.
to pull that card very quickly so coil will fall into the cup. So that is the example of inertia, right? And I will show you one more thing that what inertia will do. There are different experiment. You can see that this one also. You can make TikTok, YouTube Shorts video by performing this experiment, explaining there is also a physics involved in TikTok videos. There are multiple experiments, but let me show you one very interesting thing that also caused due to inertia.
Sir,
Yes.
I have to leave the class now. It's my math class now.
Okay, no issue. I will send the recorded lecture. You may. We are just ending in 10 minutes because we start 10 minutes late. So we will start with the Newton's first law or second law, right?
Right.
Okay.
So may I leave?
Yes, yes.
Okay,
Thank
Allah Hafiz.
Allah Hafiz. Okay, this is also a practical application, but that was not intentionally performed. You observe that there is a massive hunk of stone in the truck, and that suddenly just crashes the front compartment of the truck, right? And statement is written under the inertia, your truck has brakes, the massive hunk of stone doesn't, right? So actually it happens due to inertia. Why? Because when we are driving a truck, so now that massive hunk of stone also have a motion state, right? And it is also moving with the direction of the truck. And if you are not tightening that hunk of stone under the container and there is no barrier for that stone, so what happens when you apply brake? That stone is going to continue its motion of inertia in the same direction when it is actually moving. That is the direction of the truck also. So it strikes the front compartment of the truck. So it is also due to inertia, right? So there are multiple
Uh-uh.
applications because in old times, when we are discovering different things, we are inventing different gadgets to make our life easy. So these incidents will happen that time. So this is also due to inertia, right? So
Yes,
actually,
sir.
one more important thing you might observe in this experiment, that inertia is also depending upon the mass of an object, right? Let's suppose if there are two different persons of different masses, let's suppose one have 50 kg mass, just like me, and the other one has 90 kg mass, right? And both are start running from a starting point, same point, and someone collides. Let's suppose if 90 kg person collides with some other person, and a 50 kg person also collide with the other one. So the impact of that 90 kg person is greater than of that 50 kg person, right? Because let's suppose suddenly someone comes into the path of both people and they tries to stop themselves, but they are not able to stop themselves very quickly, because that 90 kg person needs some distance, needs some time to change the state of his or her body, right? But 50 kg person has less distance and less time to stable its body or to change its state into rest state, right? So actually inertia, because in your past papers they also asked that inertia depends upon, and there are four options: mass, weight, gravity, and any random other options too. So actually inertia depends upon the mass of a
The
body.
mass of the object.
Yes.
Yeah.
So that is
So the
also a very important concept.
so the mass increases, the inertia also increases,
Yes.
right?
Yes. Same
But there
like
is no way to calculate inertia. Like you can't
no,
calculate it.
no, no. We are not going to calculate, because to calculate inertia, what we need to do, we studied the concept of momentum, quantity of a motion, right? So when body is in motion state, to calculate the motion, we need to multiply it with the velocity. So that is the concept of momentum. That's why we don't have such formula for inertia, right?
Okay.
So inertia depends upon the mass. So now this diagram will clear you the concept of how inertia depends upon the mass, right? So actually this is the concept of inertia, right? And if we talk about Newton's first law, so Newton's first law is almost like the same concept of inertia, but there is only difference between both terms, that inertia is only related to the internal or intrinsic property of a body, right? And Newton's first law is related to the state of the body, right? It is not the internal one, it also include the external effect, right? So if we talk about the Newton's first law, in old papers they used to ask about that, right? The statement of Newton first law or second law, but now in new concept or in new pattern of paper, they never ask about Newton first law. Maybe just like once in a blue moon they ask about Newton's first second law to write the statement. So but we need to know about the statement because it is also important for our MCQ section, because sometimes they ask you to mark out the correct statement. So actually first law is body continue. Let's suppose if we consider the example of a football, if we try to roll a ball on the ground, right? So it will continues to roll on the ground, but if there is no air resistance or ground friction, right, it will continuously roll in the same direction. But due to opposite forces, suddenly it comes into rest after some time. So body or object will remain at rest or with.
Oh, I know this one. I know all the laws, but I don't know the number, like which law is it, like the first, second, third.
Okay. Yes, actually, there are three basic laws that we need to study in forces or in motion chapter. The first one is this one, which is just like a copy paste of inertia, but only there is a difference of the internal or external process. Otherwise, both gives you like a same concept. Okay, one more important thing, that I'm writing with constant velocity. I'm not writing the motion state specifically. I'm writing constant velocity because we know that we need to neglect air resistance and other forces, right? So if all forces are balanced on a body, so then body will move with constant speed or velocity, right? So velocity unless,
Acted upon by a resultant force.
yes, acted upon by a resultant force, right? You can see that it inner, but only again the difference that is related to the body mass.
Sir, is that the first law?
Yes, that is the Newton's first law,
Okay.
the statement of the first law, right?
Okay.
Just if you take the example of rest state, so that is very simple for Newton first law. If this chair is placed at any specific point, so it will remain at rest, right? Unless someone comes and push or pull that chair. So that is a very common simple law. That was Newton's first law. Now it is very simple for us, but at that time that was something new and something very special. And we know that when resultant force is not equal to zero, so there will be some speed of an object and there will be some specific direction also, right? For resultant force, so there are one or two more important thing, because that is very much important for MCQs, because in MCQs you know that if you don't know about the correct answer, so all options are look like that all are the right one. So the speed of the object can change, and the second point is the direction of the object can, if the result is not equal to zero, right? Okay, and I'm writing these 2 points. If resultant force is equal to zero, not equal, right? So that is the concept. And let's suppose if someone asks you to write the example, so we already discussed many examples, that car moving with constant speed, that is the example, or that is the application of Newton first law. book is lying on a table, chair is placed at some specific point in rest state. So all are the example of Newton's first law, right?
Okay.
And for second law, we already saw that formula F equals to ma. So actually that formula is for the Newton's second law. Actually in first law, Newton gives you the concept of force first time, right? That what is resultant and what is force actually, right? And what can force do. So first law actually gives you the concept of force. In second law, Newton's gives you the formula to calculate that resultant force, right? So in Newton's second law, Newton's second law, if we talk about the basic statement of Newton's second law and the basic concept of the Newton's second law, so Newton's second law is very much related. We can say that it gives you the basic definition of the force to calculate the magnitude of the force, right? And how we can calculate the force, we know that F equals to ma, but for the statement we can write as the acceleration of an object, the acceleration of an is directly proportional or simply proportional. So acceleration of an object is proportional to the resultant force acting on it. And firstly, just give me 2 minutes. I am ending. If you want to leave, if you have other class, so you may leave the class. You may join your second class. I'm just ending with the formula of Newton's second law. So resultant force acting on it and is inversely to the object mass. Statement of Newton's second law, and it is also very simple and very common. Let's suppose if there is an empty trolley in supermarket, and someone tries to just run with that trolley, with empty trolley. So you observe that your acceleration is directly proportional to your resultant force, because trolley is empty and you start from rest state, so you will accelerate with maximum acceleration, right? So both are directly, if you apply greater force, so your acceleration will be greater, right? But it is inversely proportional to the mass. Let's suppose you are running and someone is adding the object or different masses in your trolley, just like in the cartoons we saw that. So your speed will suddenly decreasing time by time, because your mass is increasing, because due to mass, the weight or the force of the weight is increasing in downward direction. So that will affect your resultant force, which is actually acting in the forward direction, right? And this example is also like someone hits a ball with a bat, so we apply force and it will accelerate, so it is directly proportional to it. But let's suppose if someone increases the mass of the ball, it will increase 2 times, so it will be very difficult for us to hit that ball with a same distance towards same acceleration with that force. So you need to increase the force also, right?
Sir, I have a question.
Yes.
For example, like you said, they rarely ask Newton's laws, but if they do ask the second one and I just write F is equal to ma, will I get the marks or do I have to write the wordings?
Actually, it depends. If question is for 1 mark and you just simply write that product of mass and acceleration will give you the concept of force. So in marking scheme, somehow they will give you the mass, right? But let's suppose if they ask you to state Newton's second law. So state means to write the statement. So in that case, you need to write the statement, because I always tell you that there are two types of definition. One is the conceptual, second one is the scientific definition related with the scientific term. Just like the forces, we start with push and pull, but that is not a specific definition. We need to write in terms of the kinematics form. So if they ask you to state, so then you need to write the complete statement, because for law there is particular statement, right?
Okay.
So that is the difference. And you already know the formula, F equals to ma. F represents the force, and we already discussed about the force. This is force, and we measure force in Newton, capital N. M represents the mass of a body with a small m symbol, and A is with a small. And one more and last important thing for today's class, that force and and base. So if someone asks you about that, is the direction of it will be the direction of the applied force, right? So this is the concept for Newton's second law. Okay.
Okay.
And from the statement, if you want to write the terms individually, so it is very simple, that acceleration is directly proportional to the force, but force is inversely to the mass, right? So that is the individual term that I use in the second law, because you know that both force and acceleration are directly, right? So if you increase the mass, your acceleration will decrease. Definitely, your force will also decrease, right? Because we need to apply more force to maintain our
Yeah.
acceleration. So that is the concept. Okay.